Section 5.8, Annuities. First of all, you have to remember what an IRA stands for, Individual Retirement Account. So remember that for the test. What is an annuity? An account into which someone An annuity is an account into which someone deposits an equal amount of money at equal periods or equal intervals of time. There are two types of annuities. Make sure you know what the two are. One is called an ordinary annuity. The other is called an annuity due. What's the difference? Equal deposits are made at the end of each interest period for an ordinary annuity. An annuity due, regular deposits are made at the beginning of the interest period. The money immediately starts earning interest because it's deposited at the beginning of the interest period. So you probably make a little bit more with an annuity due rather than an ordinary because you get more days of interest. The future value is the amount of money in the annuity in the account at the end of a specific period of time. We're going to be using table A12. This is on the back of the table that I gave you guys today. Future value is the amount of the deposit times the future value of $1. We'll talk about that in a little bit. And you do have to find the interest, so you have to subtract at the end. Our first example, and I'm going to break it up into steps so that we can kind of follow. It should follow that first table with the big long numbers that we did 2 days ago. Phil deposits $500 in an ordinary annuity at the end of each quarter. The account earns 6% interest compounded quarterly. So just like we did before, I'm looking at number 2, 6% quarterly would be 6 divided by 4, which is 1.5%. So with the 4 quarters, the first quarter is 1.5, second quarter is 1.5, so that would be 3%. Third quarter is 1.5, fourth quarter would be 6%. The number of periods would be quarterly, which is 4, times 2 years. So we have 8 periods and 1.5%. So we're going to flip back to the table on page A12. We're going to look at the title. It says Future Value of an Ordinary Annuity. And we're going to go down 8 and over to 1.5%. You're going to notice that these numbers are quite a bit bigger than the ones we did the other day. This one is 8.43284. So far I need all 3 of these things. How many periods, what's the interest rate per period, and then what is the table value. The future value is found just like we did the last couple days. So we take our $500, we multiply it times 8.43284, and we get 4,216.42. This is the future value. We need to find the interest. This one's a little bit different though. How much interest has it earned? So we're going to take our total, which is 4216.42. We're going to subtract out. We're not going to subtract out the $500 because that would be a huge amount of interest. But when we're looking at it, we need to take how many deposits has this thing made. In the total, it's got 8 periods, so it would make 8 deposits of $500 each. So every single time the period is just about over, the person adds $500 to it. So this is really taking 4216.42 and subtracting $4,000 off of it. So the interest, once you subtract that amount, isn't quite as big, but it'll probably be bigger than it was the other day. This is a big one that people tend to get wrong because they forget that those deposits are being made every single month. So we do need our future value, and we need all of these. You don't have to necessarily show me how you got them, but you have to show each of those numbers. Now, how do you do the future value annuity due? So suppose that Phil in example 1 had made $500 deposits in an annuity due at the beginning of each quarter in an account, earning 6% compounded quarterly. So the other percents are the same. So what we're going to do is we're going to use the answer from step 4 above. So step 4 was 42, 16, 42. Okay, the rate per period is going to be 6% divided by 4, which was again 1.5%. So that is going to look the same. So when you look at this one, what you're going to do is you're going to change this number into a decimal, which is 0.015. Remember, the decimal is 2 places to the left, and we're going to add 1 to that. So our number is 1.015. What happens is you get a little more interest because they put it in at the beginning instead of at the end. So you're going to take your future value, multiply it times 1.015, and you get 4279.67. So this is your future value annuity due. What is the total interest earned? We're going to do the same thing we did before. 4279.67. And we need to subtract out what was deposited, but remember there are deposits every month, so it's 8 times 500 once again. The only difference is this 500 is put in at the beginning instead of at the end, and that is amounting to $4,000. So interest would be 4279.67, and you subtract 4,000 out of there. 279.67. So the annuity due at the beginning of the month is $279.67 in interest. The annuity at the end of the month would be $216.42. So you can tell that you do make a little bit more interest at the end. You'll have to explain why as well. So I'm going to put why do you make more interest with an annuity due rather than an ordinary annuity. There's another test question for you, so make sure you look for that answer before we take the test. We'll go through some of these examples in class. We'll do a little practice on the whiteboards, and we'll see how we do.